Welcome to Void Realities, a place where insomnia finds wonder instead of restlessness. Here, science becomes poetry, the stars hum their silent songs, time bends like a river in the dark, and every unanswered question becomes a gentle companion. If you cannot sleep, you are not alone. Breathe slowly, let your mind float, and together, we will wander through the vast unknown. Neutron stars. What happens after a star explodes the last breath of a star? A massive star lives in brilliance, burning its fuel until the fire can no longer hold itself. You feel the weight of its silence approaching, a cosmic stillness before collapse. In its ending, the star becomes not less but more, reshaped by gravity's deep hand. Here begins the quiet unraveling of a sun's destiny. You lie back in the quiet of night, and above you a star shines. It seems eternal, steady and unchanging, a bead of light stitched into the fabric of the sky. Yet even the brightest stars are not endless. Like every living thing, they too carry a lifespan. And here you begin to follow one star at the threshold of its final breath. The star is massive, many times the weight of your sun. For millions of years it has lived in radiance, burning hydrogen into helium at its core, each reaction a tiny heartbeat of light. This fire is steady, delicate, balanced against the crushing inward pull of gravity. Without that fusion, gravity would win, collapsing everything inward. But with fusion the star glows, outward pressure meeting inward weight. A fragile equilibrium that has lasted longer than any human memory. You imagine it now, not as a point of light, but as a living, breathing giant. Its surface roils like boiling water, great waves of plasma leaping and sinking. Inside, deep beyond layers of atmosphere and convection, the core is hot enough to forge new elements. First hydrogen becomes helium, then helium becomes carbon, then carbon to oxygen, neon, magnesium, silicon, until finally, in its last efforts, the core makes iron. Iron, the end of the road for the star's alchemy. Unlike other elements, iron gives nothing back. Fusing it does not release energy, instead it consumes. The star cannot gain light from iron, and so in its heart the fire falters. The outward push that has held gravity at bay weakens. You can feel the silence, the stilling of the cosmic breath. Imagine the star at that moment balanced on a knife's edge. Its outer layers still glow, but the center has gone heavy, inert, filled with iron ash. In this instant, it is as if the star knows its fate. Gravity has been patient, waiting all this time, and now it presses inward with unstoppable force. The core begins to collapse. You might think of collapse as simple falling, but this is collapse beyond any ordinary meaning. The core shrinks from the size of a world to the size of a city in less than a second. The atoms themselves are squeezed, electrons pushed into protons, forming neutrons in a sudden, violent cascade. Energy floods outward in the form of neutrinos, ghostly particles that pass through matter almost without pause. The star groans in silence, shaking the universe with its final act. Then the rebound comes. The outer layers, no longer supported, crash inward, strike the stiffening neutron-rich core, and are hurled back out. In this instant the star explodes. It is a supernova, one of the most luminous events the cosmos can offer. For days, weeks, even months, the light of this one dying star can outshine an entire galaxy. You might close your eyes and imagine the sky brightening, a sudden unfamiliar beacon rising, reminding all who look up that endings are not quiet affairs. And yet even in destruction, creation unfolds. The explosion forges gold, uranium, and other heavy elements, scattering them like seeds across space. Dust, gas, and glowing shrapnel spread outward, enriching the galaxy. One day those atoms will gather again, forming new stars, new planets, perhaps even the bones and blood of creatures yet to exist. In this way, the death of a star becomes the gift of matter to everything that will follow. But in the center, where the blast has cleared, something remains. The husk of the star, compressed beyond the ordinary, survives the explosion. You are left with a remnant smaller than the star that was, but denser than anything your mind can comfortably hold. A core that refused to be broken, now shrunken into an object of unimaginable weight. This is the threshold, the pause at the end of the star's long breath. It has collapsed, exploded, and left behind the seed of something new. What comes next is stranger still. A form of matter so dense that a teaspoon outweighs mountains, a body so small yet so heavy that it warps space around it. You may picture it as a star, yet not a star, glowing faintly with residual heat, spinning with the memory of its old rotation. For now you linger at the moment just after the blast. The gas clouds glow, illuminated by shock waves, spreading outward in tendrils and filaments. They look almost alive, curling like smoke, drifting like underwater creatures. Silence follows the violence, a silence as vast as the cosmos itself. And in that silence a new story begins. You might feel the echo of the star's life in yourself. The oxygen you breathe, the calcium in your bones, the iron in your blood. All of it was once forged in the furnace of a star that died long ago. To follow this story is not to watch something foreign, but to trace your own ancestry back to the sky. You are, in a real sense, made of stars. Their last breath is part of your first. The dying star, then, is not an end, but a continuation. It surrenders its form so that others may live. It compresses, transforms, and prepares to become something even more extraordinary. You stand at the threshold with it, wondering what shape the future will take. Will it hold its ground as a neutron star, a city-sized ember of collapsed matter? Or will it fall further still, into the unseen depths of a black hole? The universe does not hurry to answer. It allows you to rest here, in the glow of the aftermath, watching filaments of gas paint the darkness with color. Reds, blues, and purples shimmer, drifting through vacuum, silent and patient. It is as if the cosmos itself is whispering. Endings are beginnings, and beginnings are quiet things. For now you breathe with the star, one last exhale into the night. You feel its presence dim, but not disappear. A chapter closes and another opens, the story of what comes after collapse into darkness. The star's core folds in on itself, atoms crushed beyond recognition. You follow matter as it surrenders to forces stronger than imagination. Space bends, time trembles, and density reaches the unthinkable. In this collapse, something new is born. You remain suspended in the quiet after the star's last explosion, drifting in the glow of expanding gas and dust. The colors fade slowly like smoke in still air. But your gaze turns inward to the heart that was left behind. For though the light has spread across space, the true drama lies in what remains hidden, pressed deep into gravity's grasp. At the center of the blast is the collapsed core. Imagine matter, once vast and burning, reduced to something the size of a single city. You could cross its diameter in less than an hour's drive, yet it weighs more than the sun itself. Gravity has taken hold completely, compressing, folding, and crushing the star's essence into a new form. What does it mean to collapse? In ordinary life, you know collapse as the folding of a structure, a building falling, a lung deflating, a wave subsiding. But here, collapse is fiercer. It is not the falling of something weak, but the victory of gravity over resistance. The outward push of fusion has ended, and now nothing remains to oppose the inward pull. Matter obeys without question. Picture the atoms. Each one is normally made of empty space, a tiny nucleus surrounded by electrons in vast orbits. If an atom were the size of a cathedral, the nucleus would be smaller than a grain of rice in its center, while the electrons would trace paths near the outer walls. That emptiness is what allows matter to take up volume. But under the star's collapse, that emptiness is crushed away. Electrons are forced into protons, combining to make neutrons. The cathedral falls in on itself, leaving behind a single dense stone. This is where physics stretches toward the limits of imagination. The pressure is so immense that the very identity of matter changes. neutrons packed together like bricks with no gaps between them. The result is matter that cannot be compressed further without breaking the laws of nature themselves. You let yourself drift into the image. A teaspoon of this collapsed matter weighs billions of tons. A spoonful would crush through the Earth's crust, sink into its core, and still carry unimaginable mass. You realize that density is not a number, but a feeling, the heaviness of infinity made physical. Yet it is not only matter that collapses here. Space and time themselves bend under the weight. General relativity, Einstein's great insight, tells you that mass curves space like a ball pressing into fabric. For a neutron star, the curve is so deep that light itself bends sharply around it. Time slows in its vicinity, clocks ticking differently for those near compared to those far away. To stand at its surface would be to step into another rhythm of existence, where every second is stretched by gravity's pull. You begin to feel how collapse is not destruction, but transformation. The star has lost its familiar shape, but gained a new one, strange and compact. It no longer shines with fusion's fire, yet it glows faintly from residual heat, an ember of collapsed matter cooling across millions of years. And in that collapse lies beauty. Imagine approaching such an object, its gravity tugging at you with irresistible strength. From afar you see a faint sphere, only a dozen kilometers across, yet holding the memory of a giant. Its surface is smooth, hard and alien, crusted with nuclear matter. Above it, space curves so sharply that stars behind it appear shifted, their light bent into rings and halos. The neutron star itself seems to float in a bubble of distorted night. Collapse is also soundless. When you think of such violence, you imagine thunder, rumbling, crashing. But in the vacuum of space, no air carries vibration. The collapse is silent, felt not in sound but in weight and in light. Neutrinos carry away most of the energy, ghost-like and unseen, streaming through the universe. You pause to consider neutrinos themselves, these messengers of collapse. They are particles that pass through planets, walls, and your body without pause, almost without interaction. In the instant of collapse, a flood of them is released, more than in all the stars of the universe combined, but in a single event, and for a brief moment. They slip through space unnoticed, yet they mark the precise moment when a star gave way. Still, what captures your mind is the core itself. It is no longer a star, yet it is not nothing. It is the beginning of something new, a neutron star. And this strange object born from collapse will become one of the most remarkable actors in the cosmic story. To understand collapse fully, you compare it to thresholds in your own life. There are times when you hold a balance, when opposing forces meet, effort against fatigue, light against shadow, growth against decline. And then there are moments when balance breaks, when something tips, and you fall into a new shape you could not have imagined before. That is what the star experiences, a surrender, a yielding, and the emergence of a form more condensed, more focused, more intense. The collapse into darkness is not the end, but a doorway. Beyond it lies the realm of neutron stars, the smallest, densest stellar bodies that can exist without becoming black holes. They are limits embodied, physics pushed to the edge of possibility. They spin, they shine in pulses, they generate magnetic fields of unfathomable strength. But all of that comes later. For now you remain at the moment of collapse, the instant when matter makes its choice and steps across the line into strangeness. You might imagine the universe watching, patient and calm, as one star joins the great catalogue of endings. Around you, billions of stars still shine, their own stories ongoing. But here, in this one, you see a pattern repeated countless times. Collapse is part of the rhythm of existence. It happens not only in stars, but in galaxies, in ecosystems, even in thoughts and lives. Something gives way, something falls inward, and in that falling something new is born. In this way you feel closer to the star, less a distant spectacle and more a mirror. Your own being carries collapse and rebirth, cells die, thoughts end, seasons turn. The star's story is not alien but familiar. It is the cosmic scale of what you know already in smaller ways. You drift deeper into the image, a silent core, impossibly heavy, impossibly small, surrounded by the fading light of its own shrapnel. It is darkness, but not emptiness. It is the seed of the chapters to come, where rotation, magnetism, and radiation shape new wonders. Collapse, then, is not the finish, but the crossing into another state of being. The star's breath has ended, but its presence remains altered and intensified. You stand at the edge of this transformation, ready to follow where it leads. The birth of a neutron star. From the ashes of collapse a remnant remains, small, heavy, radiant with strangeness. Its surface gleams like a frozen ocean of nuclear matter. You drift closer, tracing the new heartbeat of a star. Here lies the second life of stellar death. You hover now at the edge of silence, where the collapse has ended but the story continues. The massive star has shed its brilliance, scattered its outer layers, and left behind a core compressed into something unfamiliar. What was once a shining sun is now reduced to a sphere no larger than a city. Yet inside this smallness lies enormity. You are meeting for the first time a neutron star. It does not look like any star you know. It is not bloated with plasma like the sun, not glowing with fusion's steady fire. Instead, its light is faint and eerie, the last heat leaking from its compressed skin. Picture it as a coal still warm from a furnace, radiating not flames but the memory of flames. Its surface shines with a pale glow, white or bluish, a soft ember fading over millions of years. But the true wonder is not its light, it is its density. You drift closer in imagination, as if approaching its crust. Beneath your feet lies matter so tightly packed that 1 teaspoon would outweigh mountains. The ground beneath you is smooth, hard, crystalline. It is not rock, nor metal, nor anything familiar. It is nuclear matter, a fabric of neutrons bound together in ways that ordinary matter on Earth cannot imitate. To understand it, you return in your thoughts to the atom. Normally, an atom is a spacious thing, with electrons orbiting a tiny nucleus. But in this star, all the spaces have been squeezed away. Electrons and protons are fused into neutrons, and neutrons packed together with no gaps, shoulder to shoulder, wall to wall. The cathedral of the atom has collapsed into solid stone. This stone is the body of the neutron star. You stand in awe of its surface gravity. If you were to weigh yourself here, you would feel not your own body, but a crushing force 1,000,000,000 times stronger than Earth's. A feather dropped on its surface would strike with the force of an asteroid. No mountain could rise on such a sphere. The weight would flatten it instantly. The neutron star is nearly perfect in shape, smoothed by gravity's dominance, and yet for all its heaviness, it spins. The collapse has conserved angular momentum, that law of motion that keeps skaters turning faster when they pull in their arms. The star, once rotating slowly as a giant, now spins with breathtaking speed. Some neutron stars complete a rotation in less than a blink, turning hundreds of times in a single second. The city-sized sphere becomes a whirling top, steady and relentless, its motion preserved for eons. With that spin comes magnetism. The star's magnetic field, once stretched across its vast body, is now concentrated into a tiny remnant. It intensifies beyond comprehension, billions of times stronger than Earth's. Invisible lines of force extend into space, shaping particles and bending radiation. Already you sense how this remnant will become not just a quiet ember, but an active presence, sweeping beams across the sky. That story belongs to the chapters ahead, for now you linger at its birth. The neutron star is newly formed, cooling, stabilizing. It has survived the violence of collapse, survived the blast of the supernova, and now stands as the survivor of extremes. It is not alive in the way you are alive, yet it carries a kind of rhythm, rotation, cooling, magnetism, a heartbeat in cosmic form. Think of its crust. Beneath the surface, layers descend into stranger and stranger states. At first, a rigid lattice of nuclei like a crystalline armor. Deeper, neutrons drip from atoms, forming seas of nuclear fluid. Deeper still, matter becomes a superfluid, a state where particles move without friction, flowing endlessly like a river that never slows. Even deeper, there may be quarks themselves, the smallest building blocks of matter, unbound and swimming free. No human eye has seen such states, yet here they are real, woven into the body of the star. This is the paradox of the neutron star's birth. It is tiny, yet it contains more matter than the sun. It is simple, a ball of neutrons, yet layered with exotic physics. It is quiet, cooling in silence, yet it will send signals across the cosmos. It is a star that died, yet it continues to exist, not as absence but as transformation. You may feel as you drift near it a kinship with transformation itself. In your own life, endings often feel like voids, yet here is a reminder that endings can condense, reshape, and become beginnings. The neutron star is born not from abundance but from collapse, not from growth but from compression. What remains is smaller but more concentrated, more intense. Astronomers on Earth detect these objects not by sight, but by their fingerprints. The neutron star may spin beams of radiation that sweep past like lighthouse beams, flickering with perfect rhythm. Or it may flare as a magnetar, twisting space with magnetic fury. Or it may simply exist in quiet, a faint point of X-rays in the sky. But to know what they are, to imagine their substance, is to step into wonder. Pause and breathe with this star. You imagine yourself standing upon its surface, though no human could ever survive there. The sky above would be bent, stars appearing doubled or ringed by gravitational lensing. The ground would not yield beneath your weight, no matter how you pressed. Around you would be silence, absolute and endless, broken only by the hum of rotation and the whisper of magnetic fields. You realize that the neutron star, though alien, is not isolated from you. Its birth connects to you through the elements it scattered, the gravity waves it sent, the particles it released. You are part of its story, just as it is part of yours. Without the deaths of such stars, your blood would not carry iron, your bones would not carry calcium, your jewelry would not carry gold. The neutron star is distant yet intimate. It is also temporary. Though it may exist for billions of years, even neutron stars are not eternal. They cool, they slow, they sometimes merge with one another, giving rise to black holes and fresh explosions. Their birth is not a permanent state, but a stage in the ongoing cycle of matter. To see one is to catch a star mid-transformation, in the middle of its journey from flame to silence. The birth of a neutron star is the birth of strangeness made real. It is the proof that the universe holds forms of matter beyond imagination, waiting in silence until collapse reveals them. It is a reminder that what looks like an end may hold the seeds of wonder. As you drift back from its surface, you carry with you the image of a small, dense ember glowing faintly against the night. It is no longer the roaring star it once was. It is something quieter, steadier, and infinitely stranger. Its presence lingers in your mind like a heartbeat you can almost feel. Matter at the edge of imagination. Atoms dissolve, protons and electrons pressed into neutrons. You wander across a crust of exotic density where a teaspoon outweighs mountains. The laws of matter stretch, break, and reform into something unfamiliar. This is the substance of stars that refuse to vanish. You drift now toward the surface of the newborn neutron star, letting your mind touch what no body could ever reach. Here, matter itself has been redefined. The star no longer follows the rules of ordinary atoms. Instead, it has crossed into a realm where imagination falters, and yet the universe remains precise, unwavering in its laws. You begin at the crust, the outermost skin of the neutron star. It is only a kilometer thick, but within that thin shell, reality shifts. The upper layer holds a lattice of nuclei, squeezed so tightly that they form a solid unlike anything on Earth. Imagine walking on a surface harder than diamond, smoother than polished steel, unbroken by mountain or valley. Even the smallest bump would collapse under the gravity's weight, leaving only a perfect, seamless sphere. Step deeper, and the atoms themselves lose their form. On Earth, atoms define matter, a nucleus of protons and neutrons circled by dancing electrons. But here, pressure crushes the electrons into the protons, fusing them into neutrons. The space between particles, the emptiness that makes up nearly all of an atom's volume, is erased. The cathedral of matter collapses into a single seamless stone. You pause to imagine the weight of such matter. A teaspoon of it, if somehow carried to Earth, would weigh billions of tons. It would sink through the crust of the planet, tunnel through rock and mantle, and settle near the core, dragging everything in its path. This is the language of density beyond analogy, the universe's way of showing how much can be hidden in how little. The deeper you go, the stranger the matter becomes. At a certain depth, neutrons begin to leak from nuclei, drifting freely like droplets escaping a sponge. They form rivers of nuclear fluid, streaming through the lattice of particles. The crust is no longer solid in the way you know it, but a mixture of crystal and fluid, rigid yet flowing at once. Physicists give names to these imagined states: nuclear pasta, with forms like spaghetti, lasagna, or gnocchi, as neutrons and protons arrange themselves in bizarre, efficient patterns. These are playful names for a reality both alien and exact. Go deeper still, and the neutrons merge into a sea. The matter becomes a superfluid, a state so strange it can flow without friction, forever, without slowing. If you could dip your hand into this sea, it would slip through your fingers without resistance, without drag. It is matter perfected into flow, a river with no end. Imagine standing in that interior, though no human could. Around you, particles swirl in silence, moving without effort, obeying rules that seem more dreamlike than physical. It is the ultimate paradox, density so crushing that it creates freedom, particles moving without resistance in the tightest cage the universe can build. And then, perhaps, even stranger possibilities await in the deepest layers. Some theories suggest that at the star's core, the neutrons themselves dissolve into quarks, the most fundamental building blocks of matter. You picture it. A sea of quarks and gluons, a soup of pure subatomic essence. If this exists, it is the heart of the heart, the last step before physics itself becomes unknown. To hold these images is to walk along the edge of imagination. You cannot visit, you cannot see directly, but you can think, and in thinking, you bring yourself close. The neutron star becomes a place of wonder, not because it is beyond you, but because it is within reach of your mind. You linger on the idea of superfluidity, that silent motion without loss. On Earth, scientists create tiny samples of superfluid helium which can creep up the walls of a container, flow endlessly in circles, or slip through cracks no normal liquid could pass. In a neutron star, the entire interior becomes such a substance, scaled to cosmic size. A star, a city wide, flowing as smoothly as the calmest water, spinning without resistance for millions of years. Then you think of the nuclear pasta, the shapes that sound whimsical, yet emerge from the deepest logic of physics. Neutrons and protons arrange themselves into sheets, strands, or clusters, minimizing energy, maximizing stability. In these forms, the star writes patterns unknown anywhere else in the universe. They are the geometry of matter under extreme duress, the architecture of collapse. The neutron star's matter is not just strange for strangeness' sake. It is a laboratory of physics, a place where nature tests what is possible. Every spin, every pulse, every tremor that reaches Earth as light or wave carries information from these interiors. When astronomers measure a neutron star's rhythm, they are reading its structure, decoding the whispers of matter at its edge. For you, lying back in thought, the science becomes more than fact. It becomes metaphor. You feel the weight of density, the way everything collapses inward when outward support ends. You feel the strangeness of transformation, the way familiar structures dissolve to reveal something deeper. You feel the beauty of endurance, that even under crushing gravity, matter finds new forms, new flows, new patterns. Matter at the edge of imagination is not just physical, it is personal. You too contain layers, crusts, shells, surfaces that seem hard and unchanging. Beneath those surfaces lie rivers of feeling, currents of thought, patterns invisible to others, and deeper still, perhaps, lies a core that even you cannot fully see, a place where imagination runs thin, yet something essential endures. The neutron star reminds you that strangeness is not chaos but order in disguise. The universe does not abandon its laws, it extends them. It asks matter to adapt, and matter does, forming states that no one could predict, yet that remain consistent, precise, and real. As you step back, you imagine again the star as a whole. Small, dense, and spinning, it floats in silence, a city-sized sphere of exotic matter. It looks unremarkable from afar, just a faint point of light. Yet inside it contains landscapes that could fill volumes of wonder. Landscapes of pasta-like lattices, seas of neutrons, and perhaps quark oceans. A star remade not into nothing, but into the most unusual something the cosmos can hold. You breathe slowly, letting the strangeness settle into calm. The neutron star is a reminder that imagination, stretched far enough, can still fall short of reality. Yet that shortfall is gentle, not discouraging. It is the cosmos's way of inviting you to dream more deeply, to wander further, to keep asking. The spinning hearts of the cosmos neutron stars whirl, spinning faster than the blink of an eye. Their rotation becomes a song, steady and precise, echoing across space. You listen to the rhythm, a cosmic metronome marking time. The universe keeps its pulse in these turning hearts. You drift now away from the crust of matter, from the silent seas of neutrons, and you begin to notice motion. The neutron star, for all its stillness and density, is never truly at rest. It spins. It turns with a rhythm so precise that it could outlast the ticking of any clock. In its rotation, you begin to hear the heartbeat of the cosmos. Why does it spin so quickly? You think back to the collapse. The giant star that came before rotated slowly, lazily, taking days or weeks to complete a turn. But as it collapsed inward, it conserved angular momentum. You know this from ordinary life. When a dancer pulls their arms in close, they turn faster. When a skater tucks into a spin, rotation accelerates. The same principle applies here, magnified to stellar scale. A massive star shrinks into a city-sized sphere, and what once took days now takes milliseconds. The giant becomes a top spinning faster than the eye can follow. Some neutron stars rotate dozens of times each second. Others whirl hundreds of times in that same span. The fastest known spin more than 700 times in a single second. Imagine it. A sphere heavier than the sun, turning over and over, steady, tireless, unbroken. It is not chaos but precision. Each turn is almost identical to the last, each rotation a beat in an endless song. You might imagine standing near one, though no body could survive its gravity. From a safe distance, the neutron star appears as a faint point, dim but resolute. Yet through the rhythm of its spin, it announces itself. Light, radiation, and particles stream outward, modulated by the turning. To astronomers, this motion becomes measurable, a flicker that repeats with clock-like consistency. Here, in this turning, you begin to sense something profound. The neutron star is no longer just an object, but a timekeeper. It holds rhythm across decades, centuries, even millennia. Pulsars, neutron stars that beam light in sweeping arcs, blink so regularly that they rival the precision of atomic clocks. To study them is to listen to a drumbeat that does not falter, a reminder that the cosmos itself carries tempo. Think of the steadiness this implies. On Earth, clocks drift, machines wear, humans waver. But these spinning stars hold their rhythm across cosmic spans. Even as they slowly lose energy, even as their spin decreases, they remain faithful to pattern. Their turning is a gift of collapse, and collapse leaves nothing to chance. You let yourself imagine these stars not as objects but as hearts, Each one beats with rotation, pumping not blood but energy, not life but signal. They are hearts that never falter, hearts that outlast empires, civilizations, perhaps even species. To listen is to place your ear against the chest of the universe and hear it alive with turning. There is music in it too. Astronomers sometimes transform the pulses into sound, lowering the frequency into human range. What emerges is a hum, a series of ticks, a rhythmic thrum like the beating of drums. Each neutron star becomes an instrument, adding its voice to the cosmic orchestra. You imagine lying in the dark, surrounded by their beats, each one steady, each one unique, all together forming the pulse of galaxies. And still, the science deepens the wonder. The speed of rotation influences everything about the neutron star, its magnetism, its radiation, its ability to shine. Faster spins mean stronger beams, more energetic winds. Slower spins mean quieter, gentler stars. Over millions of years the rhythm slows, the beat softens, but the song never truly ends. The star spins down gradually, patiently, as though unwilling to let go completely. You think again of the conservation of angular momentum, that simple law you see in everyday life, extended to unimaginable scale. The turning of a dancer, the spinning of a toy top, the rotation of a collapsing star, all are connected. The universe does not separate the small from the vast. The same rules that guide your body in motion also guide stars. This connection comforts you. You are not apart from the cosmos. You are bound by the same laws, turning in rhythm with suns. You pause and breathe, letting the idea of rotation wash over you. Life itself has rhythm. The beat of your heart, the rise and fall of your breath, the cycles of waking and sleeping. The neutron star's spin is an echo of these rhythms, extended across space and time. Its rotations are too fast for your body to sense, yet the pattern they carry is familiar. Regularity, continuity, persistence, the qualities of heartbeat and breath written in the language of stars. Imagine a field of them scattered through the galaxy. Some spin like gentle wheels, others like furious tops. Their beams sweep through the night, invisible to your eyes but detected by sensitive instruments. Each one marks time not just for itself, but for the galaxy. They help scientists navigate, test relativity, and measure the universe's structure. To listen to them is to receive directions from distant lighthouses, guiding the way through cosmic seas. Yet for you, here in the quiet, the lesson is simpler. The neutron star's spin is a reminder that endings do not erase motion. Even after collapse, after explosion, after loss, something continues. The heart keeps turning, the rhythm persists, the beat remains. In this thought you find calm. You imagine the star spinning endlessly, its rotation unbroken, a metronome of the night. You imagine the tick of its pulses arriving on Earth, carrying with them not just data, but reassurance. Even across thousands of light years, the beat is steady. Even across eons, the rhythm holds. As you drift deeper into thought, you see the neutron star not alone, but in company. Many of them exist, scattered throughout galaxies, each turning, each beating, each adding its rhythm. The cosmos is not silent, but alive with countless rotations, a vast choir of spinning hearts, all playing their part in the universal song. You rest in that music, feeling its steadiness seep into your breath. The star turns, you inhale. The star turns again, you exhale. Slowly you align with its rhythm, finding calm in the certainty of its spin. And still a question stirs. If some neutron stars spin and shine with beams, what happens when those beams reach you? What if, instead of faint light, the star sends pulses across space like a lighthouse? What if its turning heart becomes not just a rhythm, but a beacon? Pulses, lighthouses in the night beams of radiation sweep across the darkness like lanterns on a boundless ocean. You watch the pulses arrive, regular as breath, guiding astronomers through the void. Each flash is both a message and a mystery. These lighthouses show us how stars whisper after death. The neutron star spins, steady and relentless, but its rhythm is not hidden. It is written into light. From its magnetic poles, beams of radiation stretch outward, sweeping space like searchlights. And if the beam crosses your line of sight, you see a pulse. Flash, pause, flash, pause. The star becomes a lighthouse of the cosmos, a pulsar. You imagine standing on the shore of a vast, dark ocean. The waves are invisible, the waters endless. Far away, a beacon sweeps across the night, turning steadily, casting arcs of light across blackness. Sometimes the beam reaches you, sometimes it doesn't. When it does, you feel the reassurance of pattern. The flash is not random, but regular, faithful. This is what astronomers saw in 1967, when Jocelyn Bell Burnell first discovered pulsars, strange signals ticking with uncanny precision, like the heartbeat of something alive. At first they wondered if it might be communication, some distant intelligence sending radio messages. The signals were so clean, so repetitive, that they labeled them LGM, Little Green Men. But soon it became clear, these were not aliens but stars, collapsed stars, turning and shining in pulses. The universe had created its own clockwork, powered by gravity, magnetism, and motion. You drift closer in thought, tracing the shape of a pulsar. Imagine the magnetic field, billions of times stronger than Earth's, twisting radiation into narrow beams. The beams shine not from the equator, but from the poles, tilted away from the spin. So as the star rotates, the beams sweep across space like arms of light. If Earth lies in the path of those beams, astronomers see the flashes. If not, the pulsar remains invisible, silent to us, though it still spins in secret. The pulses arrive with perfect timing. Some blink every second, others dozens of times per second, others hundreds. The fastest known pulse is nearly 1,000 times in a single second, faster than the blink of an eye, faster than the flutter of thought. And yet each pulse is distinct, separated, a note in an endless rhythm. To hear them is to hear time itself. Astronomers record the signals and find a regularity so precise that pulses rival atomic clocks. They use them to navigate spacecraft, to measure the ripples of space-time, to map the galaxy. Pulses become guides, not just lights but instruments, helping humans find their place in the vastness. But for you, lying in thought, pulses are more than tools, they are stories. Each pulse is the memory of a star that once burned, that once glowed across millions of years, that once collapsed into silence. Each flash is a whisper from that silence, saying, I am still here, I still turn, I still shine. Imagine watching a pulsar through a telescope. The signals arrive steady as a drum. You know the star is impossibly far away, perhaps thousands of light years, and yet its light touches you. A journey across time and space ends at your eyes or your instruments. The star is gone as it once was, but its pulses continue, messages that outlast the life of civilizations. You linger on the metaphor of lighthouses. For sailors on dark seas, the sweep of a lighthouse meant safety, direction, hope. For astronomers adrift in the ocean of space, pulses are the same. Their signals pierce the darkness, offering bearings, confirming truths, lighting the way. Even in cosmic death there is guidance. The pulses also carry individuality. No two pulses are alike. Some slow over time, their rhythm stretching like the fading tick of an old clock. Others glitch suddenly, spinning faster for a moment, as if jolted by some inner shift. Some beam strongly in radio waves, others in X-rays or gamma rays. Each one sings its own song, yet together they form a choir of lighthouses scattered across galaxies. Consider the Crab pulsar, born from a supernova witnessed on Earth in 1054. Chinese astronomers saw a new star appear in daylight, brighter than Venus. The star faded, but at its center remains the Crab pulsar, spinning 30 times a second, beaming light across the cosmos. Nearly 1,000 years later, we still see its pulses, still measure its rhythm, still connect to that ancient explosion. It is as though the star continues to speak long after its brilliant death. You may pause to reflect. What does it mean for something to shine after death? The pulsar is no longer a living star, no longer fusing atoms, no longer blazing with the brilliance of youth, and yet it shines still, transformed. Its energy is rotation, its gift is rhythm, its voice is pulse. Death becomes a new kind of life, quiet but enduring. Think also of the speed. A neutron star spinning hundreds of times per second seems impossible, yet it persists, steady and unbroken. That endurance becomes metaphor too. In your own life there are rhythms, the beating of your heart, the rising of your breath, the cycles of days and nights. Pulses remind you that rhythm carries strength, that persistence holds beauty, that repetition can be comfort. The beams sweep on, night after night, century after century. They may not care who listens, yet they reach us anyway. They reach across distance and silence, offering their pattern freely. And in that generosity you find calm. The cosmos, vast and indifferent, still produces signals that guide, that reassure, that illuminate. You imagine again the vast dark ocean, lighthouses scattered across its horizon. Each one turns, each one flashes, each one marks its place. You are not lost at sea. You are surrounded by guidance, if only you learn how to listen. And so pulses become more than objects. They become companions in the night, steady voices reminding you of endurance, of persistence, of light that does not vanish. Their pulses are both scientific fact and poetic gesture, bridging the gap between measurement and meaning. As you rest, you let their rhythm join your own. Flash, breath in, flash, breath out. The lighthouse beam sweeps, your thoughts drift, your body softens. In the regularity, you find peace. But not all neutron stars are quiet lighthouses. Some carry magnetic fields so fierce that they twist atoms, distort space, and flare with violence. These are stars of fury, not guidance. Their energy is not a steady pulse, but a storm. Magnetars, the fiercest magnets in existence. Some neutron stars carry magnetic fields of staggering strength. You feel their pull even from a distance, enough to bend atoms and twist space. They flare with violence, yet hold silence in their depths. Magnetars embody both fury and stillness. You have followed neutron stars through collapse, density, and rhythm. Now you meet their most extreme kind, magnetars. If neutron stars are embers of collapse, then magnetars are storms sealed in silence. They are rare, fewer than 1 in 10 neutron stars. Yet their presence shakes the universe with invisible force. A magnetar begins like any other neutron star, born from the collapse of a giant star. But for reasons not fully understood, its magnetic field does not remain ordinary. It grows, stretches, and intensifies until it becomes the strongest magnetic field known in the cosmos. Earth has a magnetic field, faint and protective. The sun has a field, stronger, shaping flares and winds, but a magnetar's field dwarfs them all, 1,000 trillion times stronger than Earth's, strong enough to bend atoms, to twist molecules, to tear matter apart at the smallest scales. You pause to imagine this. If you stood halfway to the moon and a magnetar appeared on Earth, its magnetic field would wipe every credit card, disrupt every electronic, and distort every atom in your body. Its influence is not local but vast, reaching across great distances. Yet the magnetar itself is small, no larger than any other neutron star. Just a city-sized sphere turning silently in the void. On its surface, matter does not behave as it does anywhere else. The magnetic pressure is so great that atoms stretch into thin threads like spaghetti, their normal shapes destroyed. Even the vacuum of space is altered. The magnetic field polarizes it, changing how light itself moves. To be near a magnetar is to live in a world where the rules of physics bend and warp, still obeying their laws, but carrying those laws into unfamiliar extremes. Magnetars are not steady like pulses. They are volatile, unpredictable. Their fields strain against themselves, snapping, cracking, releasing energy in bursts. Astronomers on Earth detect these bursts as sudden flashes of X-rays and gamma rays, the highest energy light the universe offers. In a single second, a magnetar can release more energy than the sun produces in 100,000 years. Imagine the sky erupting with invisible fire, a storm of radiation pouring outward across space. One such flare was recorded in 2004 when a magnetar just 50,000 light-years away, distant yet within our galaxy, released a giant burst. The radiation washed over Earth, harmless to life but powerful enough to affect satellites and instruments. For a moment our planet felt the echo of a starquake, a tremor in a magnetic field so intense that even across cosmic distance it left its mark. You linger on the word starquake. Just as Earth's crust can shift and crack, releasing earthquakes, a magnetar's crust, under the strain of its magnetic field, can fracture. The release shakes the entire star, sending ripples through its body and its field, unleashing bursts of light and radiation. These quakes are the voice of magnetars, sudden and violent, yet they fade quickly into silence. Imagine the paradox, a body so small, silent and dark, yet capable of storms that outshine galaxies. To see a magnetar is to see fury bound into a seed, violence contained in stillness. It is a reminder that even the smallest things can hold unimaginable power. You think of the magnetic field itself, invisible yet present, like lines of force flowing outward into space. On Earth you see their traces when iron filings arrange themselves, or when a compass needle aligns north. But around a magnetar, the field is so strong it shapes reality itself. If you could see it, you would behold arcs of energy stretching into space, curling and snapping like solar flares magnified beyond comprehension. The star sits at the center, quiet and implacable, while its field rages around it. This duality, silence and violence, stillness and storm, makes magnetars so haunting. They spend most of their lives unseen, quiet, cooling, their fields coiled tight. Then in sudden flares they announce themselves, only to fall silent again. They are like hearts that beat rarely but with explosive force, pulses not of light but of upheaval. To reflect on a magnetar is to reflect on extremes. You consider how something so small can command so much influence. You think of how invisible forces like magnetism shape worlds and lives, unseen yet essential. You realize that not all power shines brightly. Some power lies hidden, waiting, coiled and restrained, until the right moment to release. And still, you sense beauty. The magnetar's flares, though dangerous, illuminate the galaxy in ways no ordinary star can. Their bursts carry information, revealing the structure of matter under impossible strain. By studying them, scientists learn about the behavior of dense matter, of magnetic fields, of physics itself. Magnetars become laboratories of the extreme, places where the laws of the universe reveal their full stretch. In your imagination, you picture lying beneath one. The surface is smooth, crystalline, unyielding. The airless sky above bends with distorted light. Invisible lines of magnetic force arc around you, tightening, humming, silent, but immense. You feel the weight of possibility in every moment, the calm of now, the threat of flare, the certainty that even in silence energy seethes. You return to yourself, lying quiet, listening to your own breath. You think of your own hidden fields, the energies within you that others cannot see. Magnetars remind you that unseen forces are often the strongest, that silence can contain storms, that stillness can mask extraordinary strength. As you rest in that thought, the magnetar softens in your mind. It is not only a storm, but also a reminder of resilience. It survives collapse, endures density, holds its structure against unimaginable pressure. Its bursts are not chaos, but release, the natural breaking of tension when strain grows too great. Even stars must yield, must quake, must flare, before returning to quiet. The magnetar remains in the night, invisible yet present, a sphere of fury and calm. Its field extends outward, touching galaxies, affecting light itself, altering the cosmos in subtle ways. It is both hidden and immense, both fragile and unbreakable. And as you drift deeper into rest, you realize the story of magnetars is not finished. For some, the strain grows so great, the companionship so close, that they find another of their kind. And when two neutron stars, whether pulsars, magnetars, or quiet remnants, meet, the universe itself trembles. The dance of binary stars. Sometimes two neutron stars find each other and orbit in an endless embrace. Their spiral sends ripples through space-time, a slow waltz of gravity. You drift with them, hearing waves that no ear can catch. In their union, the universe itself begins to tremble. You have seen neutron stars in solitude, dense, spinning, magnetic, sometimes flaring, sometimes pulsing. But now imagine two of them together, not alone, but bound. Two collapsed hearts, locked by gravity, circling each other across millions of years. This is the dance of binary neutron stars, an embrace so powerful that it shakes the very fabric of space-time. Binary stars are not unusual. Most stars in the universe are born with companions. They form together from clouds of gas, coalescing side by side, orbiting one another from the beginning. Sometimes both are ordinary stars, burning steadily in tandem. But when they are massive enough, their lives end in collapse. One supernova, then another, leaves behind not two glowing suns, but two neutron stars, compact and silent, still tied to each other by gravity's invisible thread. You picture them now. Two spheres no bigger than cities, each weighing more than the sun, circling, circling, circling. They move in silence, their paths perfect, their orbits steady. They do not touch, not yet. Instead, they spiral slowly, like dancers moving closer with every step, losing energy to the ripples they create in space-time. These ripples are gravitational waves, disturbances in the fabric of reality itself. Einstein predicted them a century ago. When massive bodies accelerate, they send waves outward, like pebbles dropped into a cosmic pond. But unlike water waves, gravitational waves do not move through space. They are waves of space. They stretch and compress reality as they pass, tiny distortions that spread across the universe. From Earth, these waves are unimaginably faint. A passing gravitational wave might stretch your body by less than the width of an atom, then compress it back again. And yet, with instruments of exquisite sensitivity, scientists have learned to listen. In 2015, LIGO, the Laser Interferometer Gravitational Wave Observatory, detected such waves for the first time from two colliding black holes, and in 2017 it heard the union of two neutron stars. Humanity caught the sound of their dance. You pause and imagine what that sound is like. Not a roar, not a crash, but a chirp, a rising tone quickening as the stars spiral closer, higher in pitch until the moment of collision. It is the music of gravity, too deep for ears, yet audible when translated into sound. It is the rhythm of two hearts that have danced for millions of years, finally joining in a single step. But before the end, there is the dance itself. For millions, even billions of years, binary neutron stars orbit quietly. Their paths decay slowly, imperceptibly, as they radiate energy into the cosmos. The universe is vast and patient. It does not hurry. The stars circle endlessly, their motion graceful, steady, precise. Imagine standing at a distance, watching them orbit. You would see two faint points of light moving around each other, pulling each other into perfect ellipses. You would see their gravity warp the space around them, lensing the light of background stars, bending paths of photons like threads around spinning wheels. The stars seem quiet, but their presence reshapes the night. And then consider the intimacy. Two stars, remnants of collapse, bound together more closely than any companions in the sky. Their orbits are not casual but essential. Each depends on the other, each shapes the other's path. Alone they would simply spin in solitude. Together they create music that resonates through the fabric of space. Binary neutron stars remind you that even in the vastness, companionship endures. The universe is not built only of solitude, but also of unions, of pairings, of relationships that last across eons. The stars may not feel, but their dance is a lesson. Gravity itself weaves companionship into the cosmos. Over time, their orbit shrinks. The dance accelerates, slowly, almost imperceptibly at first. then faster and faster still. The closer they come, the more energy they release as gravitational waves. The waves ripple outward, carrying the story of their embrace across galaxies. To us, they arrive as tiny shivers in reality, but to them, it is the culmination of their union. You pause again and breathe with their rhythm, wide orbit, slow, calm, tighter orbit, quicker, more urgent, tighter still, the pace of a drumbeat, the spin of a wheel, the pulse of a heartbeat racing. The stars close in. Their dance approaches its final step. Before the end, though, there is a profound stillness. For all their motion, binary neutron stars are silent in the way of space. No sound carries between them, only waves of gravity and bursts of light. Their quiet is not emptiness but presence. It is a reminder that some of the most powerful forces in the universe act without noise, without spectacle, without flare. And then, finally, the end arrives. The two neutron stars spiral together, orbiting hundreds of times per second until they collide. The union releases not just gravitational waves, but light, heat, and matter. Gold, platinum, uranium, heavy elements forged in their death throes, scatter into space. The collision becomes a forge, seeding the cosmos with the building blocks of worlds, of lives, of jewelry on human hands, of oxygen in human lungs. When astronomers witnessed such a collision in 2017, they saw not only gravitational waves but also light, a kilonova, brighter than 1 billion suns, glowing for days. They measured the elements created, confirmed the origin of gold and silver and rare earths. They realized that the wealth of planets, the richness of chemistry, the very matter of human civilization was born in dances like these. You rest in this knowledge. The ring on a finger, the coins of history, the wires in machines, all trace their ancestry to stars that once danced and collided. Binary neutron stars are not only wonders to observe, they are ancestors of matter itself. Their love, if you can call it that, is written into you. And so, the dance of binary stars becomes more than astronomy. It becomes metaphor. In your life too, there are unions that shape you, forces unseen that pull you into rhythm with others. You orbit, you are orbited. You move in paths shaped by invisible ties. Sometimes those paths last, steady and enduring. Sometimes they draw tighter, faster, toward endings that are also beginnings. The binary neutron stars remind you, companionship is powerful, union is creative, endings can scatter seeds for futures yet unknown. Their dance is a story of both beauty and inevitability, of grace and collapse, of destruction and creation intertwined. And when the collision is complete, something new may emerge. Sometimes the union forms a larger neutron star, spinning even faster, blazing with energy. Sometimes it crosses the threshold into a black hole, collapsing past the point of no return. Whatever the outcome, the dance does not vanish. It continues in echoes, in gravitational waves spreading outward, in heavy elements drifting through galaxies, in the memory of rhythm etched into space-time itself. You close your eyes and imagine two stars circling in silence, bound by gravity, joined in patience, destined for union. Their embrace is not hurried. It lasts millions of years, and yet every turn, every step leads to the same end: collision, creation, transformation. Collisions, when stars merge. Two neutron stars collide and the cosmos shudders with light and gold. Elements are born, scattered into galaxies, seeding the matter of life. You witness creation within destruction, beauty within violence. From the crash of stars, your own atoms once arose. The dance of binary stars carries you forward, and now you reach its climax. After millions, perhaps billions of years of circling, the stars draw so close that they can no longer resist their fate. Gravity pulls them together in an unstoppable embrace. Two neutron stars merge, and the universe trembles. It begins gently, almost imperceptibly. Their orbits shrink, their spins accelerate, their pulses quicken. The gravitational waves grow louder, like a drumbeat rising. From afar you might hear them as a chirp, the pitch climbing higher and higher until it peaks. Then in one final instant the stars touch and everything changes. When neutron stars collide, the energy released is staggering. For a brief moment the brilliance of their merger can outshine an entire galaxy. Space itself ripples violently. The collision sends shock waves through matter, light, and gravity alike. To imagine it, you must stretch your senses. The flash of X-rays and gamma rays, the roar of gravitational waves, the spray of particles hurled into space. It is chaos, and yet it is creation. The most astonishing gift of these collisions is matter itself. In the furnace of their union, elements heavier than iron are born. Gold, platinum, uranium, and other rare elements form in vast quantities, then scatter outward into space. The rings you wear, the circuits in machines, the metals in Earth's crust, all trace their origin to collisions like this. You are not only stardust, you are merger dust, made from the wreckage of neutron stars. Pause and let this thought sink in. The atoms in your body carry stories older than Earth. The calcium in your bones was forged in ordinary stars, the oxygen in your breath born in stellar fusion. But the gold in your jewelry, the iodine in your body, the rare earths in your electronics, these came from neutron star collisions, from moments of unimaginable violence and beauty. Every time you hold such elements, you hold the memory of stars that once shattered. The collision itself is a ballet of extremes. Imagine the two stars approaching, their crusts cracking, their interiors deforming under the strain. They stretch into teardrop shapes, pulled by tidal forces, then slam together with such force that matter sprays outward in arcs of molten neutron-rich material. These arcs glow, shining brighter than billions of suns, fading slowly over days. Astronomers call this light a kilonova, an explosion less energetic than a supernova, yet luminous enough to be seen across galaxies. Kilonovae are more than spectacle. They are signals carrying the fingerprints of elements newly formed. When astronomers measured the light from a neutron star collision in 2017, they saw the signature of gold and platinum. They knew then, with certainty, that much of the universe's precious metals came from these rare events. A human longing for gold, for adornment, for currency, for meaning, is ultimately a longing for the remnants of colliding stars. Yet beyond metals, the collision offers something else, gravitational waves. As the stars spiral and merge, they send ripples outward through space-time. These waves travel not as light does, but as distortions in reality itself. They stretch and compress distance, silent to human senses but detectable with exquisite instruments. When LIGO and Virgo observed such a collision, they did not just see light, they heard the universe in a new way. It was as if nature had added another sense, another dimension of listening, another voice in the cosmic chorus. You may picture yourself lying still, feeling the faint tremor of such waves passing through your body. You would not notice them. They are far too small. And yet they pass, stretching you thinner than an atom's width, compressing you back again, rippling through the earth unnoticed. The universe shakes, and you too are part of that motion. As the collision unfolds, its outcome depends on weight and chance. Sometimes the merger forms a larger neutron star, spinning at incredible speed, blazing with magnetic fury. Other times the mass is too great, and the star collapses further, crossing the threshold into a black hole. In either case, the result is transformation, something new born from union, something beyond the two stars that came before. You reflect on this duality, destruction that is also creation, endings that are beginnings. The neutron stars vanish as individuals, but from their collision arises light, waves, and matter that enrich the cosmos. Their death is not an absence, but a contribution, a scattering of gifts across galaxies. Even silence becomes luminous, even collapse becomes generative. To hold this in mind is to see your own life in the same pattern. Collisions are not always gentle. They can be painful, shattering, overwhelming. Yet even from such impacts, something new can emerge. Growth, connection, transformation. The universe itself is shaped by collision. Galaxies merge, stars collide, black holes swallow, and from each union comes change, sometimes violent, sometimes beautiful, often both. The neutron-star collision is also a reminder of scale. These stars, so small compared to the galaxies they inhabit, hold enough energy to change the chemical makeup of the universe. Small things, dense with possibility, can alter everything. You too carry that paradox, small in size compared to the cosmos, yet dense with meaning, capable of influence beyond what appears. As the kilonova fades, its light dims into the fabric of night. The arcs of matter cool, drifting outward, to mix with gas and dust, to seed future stars and planets. The gravitational waves move on endlessly, crossing billions of light years, never slowing, never fading, carrying the record of the collision into eternity. The stars themselves are gone, yet their story persists in echoes. Astronomers on Earth continue to study such events, each collision a natural laboratory. By watching them, they learn about the structure of neutron stars, the nature of matter, the truth of gravity. But beyond science, these collisions leave an imprint on imagination itself. They remind you that the universe is not static but alive, dynamic, creative even in its violence. You close your eyes and picture the moment again, two stars spiraling, colliding, dissolving into light and gold. The image stays with you, glowing softly in your mind. It is not frightening, not overwhelming. It is slow, rhythmic, inevitable, like the tide pulling waves to shore. It is the universe exhaling creation through destruction. And as the light fades, you find yourself wondering, what comes after? If two neutron stars can merge into a black hole, what lies beyond that horizon? What happens when matter collapses further, past even the limits of neutron stars? Black holes, the final threshold. Some stars collapse past even the neutron state, slipping into shadows deeper still. You follow matter as it crosses horizons that never return. Between neutron stars and black holes lies a delicate line of fate. Here the story of death becomes the story of forever. The neutron star is dense, small, astonishing. But there is a limit even here. Push harder, press deeper, and nature itself cannot hold. Gravity wins without resistance. The star collapses not into a denser stone, not into a stranger matter, but into a silence absolute. What remains is no longer a star. It is a black hole, the final threshold of collapse. To imagine this, you begin at the edge. Picture a neutron star on the brink, too massive to survive. Its own gravity presses inward, beyond the ability of neutrons to resist. The crust buckles, the core caves, the very fabric of matter breaks. There is no pause this time, no remnant to balance the pull. The collapse continues, unstoppable, until the star vanishes into a point, a singularity. At its heart, a black hole is simple and absolute, matter compressed into infinite density, space-time curved infinitely inward. Yet the singularity itself is hidden, cloaked behind a boundary called the event horizon. This horizon is the edge of return. Cross it and escape is impossible. Not even light can leave. You rest on the image of that horizon. It is not a wall, not a surface, not something tangible. It is a boundary of possibility. From the outside you may circle it, measure it, describe its size, but to cross it is to surrender. From within, no signal, no particle, no flicker of light can ever emerge. It is the cosmos's most perfect silence. The event horizon bends light around it, warping the view of the sky. Stars behind a black hole appear distorted, curved into arcs, stretched into rings. If you floated near one, you would see the night rearranged, a mirror of space bent by gravity's grip. The black hole itself would appear as a sphere of darkness, edged by the glow of warped starlight, a hole not in matter but in perception itself. And yet black holes are not only absence, they shape galaxies. At their centers, supermassive black holes anchor billions of stars, their gravity binding spirals and clusters. Smaller black holes form from collapsed stars, drifting in pairs or alone, silent wanderers. They are not voids of destruction, but structures of stability, shaping orbits, guiding motion, influencing cosmic architecture. Matter that falls toward a black hole does not vanish immediately. It swirls first in an accretion disk, heating to brilliant light as friction and gravity tear it apart. The disk glows with X-rays and gamma rays, sometimes forming jets that shoot particles outward at nearly the speed of light. Paradoxically, black holes, the very definition of darkness, can also be some of the brightest objects in the universe. You consider the fate of time itself near the event horizon. According to relativity, time slows in strong gravity. If you watched a clock near the horizon, it would tick more slowly than your own. To you, the falling object would freeze, its last moments stretched into eternity. But to the object itself, time would flow normally. It would fall, cross, and pass beyond, never to return. The duality is haunting. Two truths, both valid, depending on where you stand. The singularity at the center is where physics falters. Density becomes infinite, equations break, meaning dissolves. Here is the edge not only of matter, but of knowledge. Beyond it, science cannot yet follow. Perhaps it is a point, perhaps a loop, perhaps a doorway into something else. The black hole holds its secrets tightly, offering only silence in answer. And yet there is a paradox. In the 1970s, Stephen Hawking showed that black holes are not entirely black. Quantum effects at their horizons allow them to emit faint radiation, now called Hawking radiation. Over immense spans of time, this radiation can cause black holes to evaporate, shrinking until they vanish. Even these ultimate objects are not eternal. They too breathe, though in whispers stretched across trillions of years. This paradox leads to questions still unresolved. If black holes evaporate, what happens to the information of what fell inside? Can the past be erased completely, or must it somehow persist? Physicists debate, wrestle, propose, and wonder. The black hole remains both fact and mystery, a place where understanding falters, where imagination must step in. You pause and rest in this mystery. The black hole is both frightening and beautiful, both absolute and elusive. It is not an end so much as a horizon, the boundary between what we know and what we do not. In its darkness lies possibility, questions that reach beyond science into philosophy, into wonder, into silence. Reflect too on the metaphor. Black holes are collapses, thresholds, transformations. They are the moments in life when something disappears, when no light seems to escape, when all paths lead inward. Yet even here, creation continues. Black holes shape galaxies. Their accretion disks blaze. Their mergers send gravitational waves that we can detect across the universe. Even in darkness, influence radiates. Even in silence, presence remains. You imagine again the final threshold of a star. Once it burned, brilliant and vast. Once it collapsed, strange and dense. Now it has gone beyond, surrendered completely to gravity. What began as fusion and fire ends as silence and shadow. Yet in this silence lies depth, a place where even time bends, where even space curves inward, where even imagination struggles. Astronomers do not see black holes directly. They see their edges, the glowing disks, the jets, the orbits of stars whipped around them. They measure their influence, their shadows, their ripples. In 2019, for the first time, the Event Horizon Telescope captured the image of a black hole's silhouette, a dark circle ringed by glowing light. The image was blurry, imperfect, but profound. It was proof that the horizon exists, that even the most invisible of objects can be traced. From Earth, you look at that image and feel both small and connected. The black hole is not a monster waiting to consume. It is a stage in the life of matter, a structure as natural as stars and planets. It is the cosmos showing you its limits, inviting you to wonder what lies beyond them. As you drift toward rest, the black hole becomes not a threat, but a symbol. It is the ultimate collapse, the final surrender. And yet it is also the ultimate threshold, the edge of knowledge, the boundary of perception, the frontier of imagination. To follow stars to their end is to reach this point, where silence holds all questions and where the story pauses before something new. Echoes across the universe. Neutron stars leave signals, gravitational waves, bursts of radiation, whispers in radio. You listen to the cosmos like an ancient ocean, each ripple carrying memory. These echoes remind you that stars never truly die. Their voices linger in the silence of space. The stars collapse, merge, and sometimes vanish into black holes. Yet their stories do not end there. Across the fabric of space, faint signals linger. Like ripples spreading from a stone tossed into water, these echoes move outward endlessly. They are the voices of neutron stars, carried not in words but in waves, in bursts, in whispers of light. You begin by listening for gravitational waves. They are not sounds in air, but distortions in space-time itself, stretching and squeezing reality as they pass. When neutron stars dance in pairs, when they spiral inward and collide, they send these waves outward. To us they arrive as the gentlest of tremors, smaller than the width of an atom. And yet, with instruments like LIGO and Virgo, humanity has learned to hear them. The universe reveals its rhythm, not in light, but in motion. To imagine them, you picture yourself floating in a calm ocean at night. The water feels still, yet every so often a ripple touches you, gentle, barely noticeable, but proof of motion far away. Gravitational waves are like that, soft reminders that somewhere stars moved, collided, transformed. You are connected not by sight, but by feeling. The universe pressing its story gently into your existence. But the echoes are not only in waves. Neutron stars also speak in bursts of light. Magnetars flare, releasing X-rays and gamma rays that travel across galaxies. Pulsars beam radio waves in perfect rhythm, ticking like clocks, sending signals that repeat for centuries. Astronomers tune their instruments to these frequencies, listening as though to lighthouses flashing across a cosmic sea. You imagine lying beneath the sky, ears attuned not to sound but to signal. The radio pulses arrive like heartbeats, steady, patient. The bursts from magnetars come as sudden cracks, starquakes that shake space with energy. Together they create a symphony of signals, overlapping, layered, woven into the fabric of the cosmos. Each star leaves its signature, its echo, its lingering voice. One of the most haunting of these echoes is the fast radio burst. For years, scientists puzzled over sudden, powerful blips of radio light arriving from far beyond our galaxy. Some lasted only milliseconds, yet carried as much energy as 100 million suns. Many were traced back to magnetars, neutron stars whose magnetic flares can release energy in explosive bursts. Imagine that. A starquake on a collapsed star, sending a signal that travels across billions of light years, only to arrive here as a brief flicker on a radio telescope screen. A whisper from the farthest reaches of time and space. These echoes do more than astonish, they carry memory. By measuring them, scientists learn about the density of neutron stars, the strength of gravity, the structure of space-time itself. The signals become not just echoes but messages, allowing us to understand what cannot be touched or seen directly. In listening, we learn. Pause here and think of the metaphor. You, too, leave echoes. Every choice, every word, every action ripples outward, touching others in ways you may never see. The neutron stars remind you that even after collapse, even after silence, something continues. Presence lingers in echoes, stories outlast endings. Consider the crab pulsar again. It spins 30 times each second, sending pulses of light across space. That light began its journey nearly 1,000 years ago, when the star exploded in 1054. Today the pulses still arrive, reminders of an explosion witnessed by ancient astronomers. The star is gone in its old form, but its echo endures, visible in telescopes, audible in radio signals, present in our instruments. You realize, too, that these echoes are not fragile. Gravitational waves travel without weakening, crossing billions of light years unbroken. Light from pulsars continues, flashing steadily across cosmic time. Bursts from magnetars shout their presence across unimaginable distances. The universe is vast, but the signals persist. They are testaments to resilience, endurance, and connection. In 2017, when two neutron stars merged, astronomers detected both gravitational waves and light from the collision. For the first time, humanity heard and saw the same event through different senses. It was as if the universe whispered and shouted at once, offering a fuller story. That moment changed astronomy forever, opening the age of multi-messenger astronomy, where echoes are not singular but layered, each carrying part of the truth. You might imagine yourself as one of those instruments, attuned not to noise but to presence. The sky is not silent, but filled with signals, overlapping, streaming, waiting to be interpreted. To lie beneath the stars is to bathe in echoes, though your senses are too narrow to feel them. Still, they touch you. They pass through your body, your home, your planet, leaving subtle traces you cannot perceive, but that are nonetheless real. And beyond science, the idea of echoes offers comfort. A neutron star's echo is its continuation. Its life as a blazing sun ended, but its signals endure. They remind you that endings are not final, that traces remain, that memory is carried forward in waves and light. Perhaps your own life is the same. Perhaps the echoes you leave, though invisible to you, ripple onward in ways you cannot predict. Imagine now floating in a cosmic sea, surrounded by the signals of countless stars. Pulses arrive, regular and steady. Bursts crackle, sudden and bright. Waves pass through, stretching and compressing the space around you. You are adrift in echoes, immersed in the voices of stars. Their stories are not gone. They are all around you, carried endlessly outward. As you let this vision soften, you begin to drift into the deeper meaning. The echoes of neutron stars are not only about physics or measurement, they are about memory, connection, and presence. They show that nothing is ever truly lost. Even silence speaks, even absence leaves ripples. The universe remembers in light, in waves, in echoes that endure. And yet, as haunting and beautiful as these echoes are, they carry you towards something even more intimate. For the final echoes do not linger only in signals across the sky. They live within you. The elements of your body, the atoms of your bones, are the lasting whispers of these stellar events. You do not just listen to echoes. You are one. You, the stars, and forever. The iron in your blood, the gold on your hand, the calcium in your bones, all are gifts from stellar deaths. You are stitched together from the ashes of neutron star collisions. To know them is to know yourself, the child of explosions. The stars end, and yet they live in you. You have followed the story of stars, their burning, their collapse, their pulses, their unions, their collisions, their echoes. You have drifted across waves and stood at horizons, and now you turn inward to yourself. For the final chapter of this journey is not only about neutron stars, it is about you and the ways you are made of them. Consider your body, quiet in the night. Breathe slowly and feel the air fill your lungs. The oxygen you inhale was forged in stars that lived and died long before Earth was born. It was created in fusion, in the heat of stellar cores. Every breath you take is a communion with the past, a conversation with suns that ended billions of years ago. Touch your bones, your teeth, the structure that holds you. The calcium there was also born in stars, fused in their final stages, scattered by supernovae. Without those explosions, your skeleton would not exist. The very ability to stand, to move, to live in this form is a gift from stellar death. Now think of the blood flowing within you. Its redness comes from iron, and that iron too is ancient. Iron is the element that ended the lives of massive stars, the weight in their cores that led to collapse. When you feel your heartbeat, you are feeling the pulse of iron, and therefore the pulse of stars that once gave their lives. Even the rarer parts of you trace their origins to neutron stars themselves. The iodine in your body, necessary for life, was made in collisions. The gold on your ring or earring, the platinum in circuits, the rare metals that carry electricity in machines, all were created in Colonovae when two neutron stars merged. You carry their story not just in theory, but in matter, written into your cells, your jewelry, your world. You are quite literally the child of explosions. Every atom heavier than hydrogen and helium was forged in stars, carried outward by their endings, gathered again into planets, oceans, forests, and bodies. You are a tapestry woven of cosmic memory. When you look at the stars, you are not looking at strangers. You are looking at your ancestors. Pause and breathe. Let this truth settle into you. You are not separate from the universe. You are its continuation. The elements of your body are ancient, but they are alive in you, arranged into thought and movement, into breath and dream. To know neutron stars is to know yourself more deeply, to see your own life as part of a story that began long before humanity. There is comfort in this. You may sometimes feel small, fragile, fleeting. Yet the atoms that make you are vast in history, resilient in journey, infinite in cycle. The calcium in your bones will one day return to earth, to soil, to ocean, to air. The iron in your blood will return to dust, and perhaps someday those atoms will gather again in another world, another being, another form. In this way you are not only made of stars, you are destined to return to them. Think again of the echoes. Neutron stars leave pulses, waves, and bursts crossing the universe. You too leave echoes. Your words, your actions, your love, your presence ripple outward. They may seem small, but like gravitational waves, they travel farther than you know. Someone remembers, someone is shaped, someone carries your echo forward. You are part of the ongoing chorus of existence, not isolated, but woven in. As you drift deeper into reflection, imagine the great cycles of the cosmos. Gas clouds collapse into stars, stars burn, shine, and end. Their deaths create new matter, which gathers again into planets, oceans, and life. Then life looks upward, wonders, and remembers. You are both participant and observer in this cycle, both made of it and capable of seeing it. You are a way for the universe to know itself. Neutron stars, with all their strangeness, are part of that cycle. They are reminders that endings are beginnings, that collapse is transformation, that even silence carries presence. To know them is to feel less afraid of endings, more aware of continuity, more open to wonder. Close your eyes and picture yourself lying beneath the stars. Above, the night is filled with light, some of it from nearby suns, some from galaxies far beyond, some from explosions long gone, their signals still traveling. Within you, the same elements shimmer, carried forward. You are both beneath the stars and among them, both gazing upward and glowing within. The final threshold of this journey is not out there, beyond black holes or collisions. It is here, in the recognition that you are part of forever. Not in the sense of endless individuality, but in the sense of continuity, of atoms and echoes, of presence that never fully disappears. When you breathe stars. When you move, you carry their matter. When you love, you ripple the universe. You are not a visitor in the cosmos. You are its expression, its child, its continuation. And so the story of neutron stars comes full circle. From the last breath of a star to collapse to neutron stars, to pulses and magnetars, to collisions and black holes, to echoes across the universe, all of it lives now in you. You are the final chapter. Rest now in that knowledge, rest in the calm of continuity, the rhythm of cycles, the silence of stars that is also the silence of your own breath. The universe is vast, but you are not lost in it. You are written into it, as surely as light is written into night.